So the last thing that we're going to cover in perception is a very near and dear topic to me. This was one of my areas of research was in picture perception. So we're going to end our look at picture perception, starting with the basics of picture perception and then going all the way into some things that pictures are able to do that the natural environment is not able to do, specifically metaphorical pictures. But the roadmap for what we're going to be looking at for the rest of today, we'll start off with why should you actually study picture perception? So why is this an area that is important if you're a visual researcher, if you want to understand psychology? Why do we need to understand picture perception? And then we're going to get real basic. We're going to start right at the beginning with what actually is a picture. And we'll see how many of these definitions we can actually get through, including mine, which I included there for reasons which will come up later. And then we'll see how far we get, but we'll talk about the final objection, which is metaphoric images, and then what that means for our visual system and understanding our human minds. All right, so why study picture perception? Well, there's a couple of reasons, probably more than a couple, but there's a few really important reasons. One of them is just scientific curiosity. So I am a firm believer in the idea that understanding our world, just to understand it, is a noble endeavor. It's a worthwhile endeavor, and it's something that we should be engaged in. So we can perceive pictures, and that is just something that we should have an explanation for. If we want to understand the human mind, we need to understand how we can perceive pictures. And whether or not that's going to have applications down the road, and this goes for just about any science, I think that's not something that we could ever know. So it's just better to understand the universe that we live in and the universe of our human mind, rather than imposing value judgments on whether this is something that is worthwhile of study and this is something that is not. So we can perceive pictures. So we want to know, how can we do it? So the fact that we can perceive pictures, that's that computational level of Mars tri-level hypothesis. This is something that we can do. So I showed you caricatures and you had correctly identified the individuals. I'm going to show you some images today. You'll be able to correctly identify what those images represent. This is a computational level description of what we can do. So then we want to know, how do we do it to get that full explanation? So we need to understand it at the representational level as well. We need to come up with some theories about how do we perceive these pictures. Another reason that studying picture perception is crucial to understanding visual perception is that it's a very challenging test of perception theories. So you can have theories of perception that work great in the environment, but if they cannot explain how we perceive a picture, then they are at best incomplete and at worst incorrect. So if you have a theory of perception, and there have been theories of perception that fell apart when it got to the picture perception stage, they can't possibly be a complete theory of perception, so we need to add to it to explain picture perception, or they cannot be correct. Because we can perceive pictures, we need a theory that can explain it. And the reason that this is so incredibly challenging is because our visual system was not made to perceive pictures. That was not what it was evolved to do. So if you take a look at the ecological psychology framework that we mentioned previously, you can see that it's the organism in an environment, right? We take a look at surfaces in a medium. We're an organism in an environment. We have this active role. When we were developing our visual system, in the entire time that we were developing our visual system, and it doesn't matter how far back you go in human evolution, you can start off with the single-celled, beginnings of life. As we were developing our visual system to get to where we are today, at no point were we not an organism in an environment? So in this entire chain, every single step along the way was an organism in an environment. However, only here at the end, when we get to Homo sapiens, did we have pictures. And in fact, it wasn't even when Homo sapiens kind of, finished their development, we got pictures. So that was about, what does it say there, 160, 180,000 years ago is when Homo sapiens basically were like, complete. We're done. We have basically developed into Homo sapiens. The earliest cave paintings happened around there at about 50,000 years ago. So our visual system was fully formed not to perceive pictures, and yet we can perceive pictures. So it was completely made, done, set, and then pictures were invented. So they are a very artificial thing to perceive, and yet we do have this ability to perceive pictures. So they're a wonderful test to kind of determine and explain, or try to explain, how our visual systems actually work. So our visual system was not made to perceive pictures. Picture perception, therefore, had to piggyback on any already existing visual system. And then what that means is that it's a great test. It's putting the visual system in an artificial situation that allows us to see the cracks and the limits and the intricacies of that visual system that we're studying. And again, any theory that proposes to explain vision has to explain picture perception, has to be able to explain how it is that we perceive and perceive correctly when we look at pictures. So it is one of those just great tests for visual perception theories. So it's one of those things where if you can get picture perception correct, you're almost guaranteed to get perception in the environment correct. But if you go the other way, you're not guaranteed to get picture perception correct. If you can explain the environment, you might still need added concepts, added ideas, added strategies to explain picture perception. So it's a great place to start, kind of paradoxically, if you want to develop a theory that understands how we perceive everything, including pictures. All right, so what I'm going to do right now, as we continue our look at what is a picture, I'm going to show you some pictures by the children of Sunningdale School in Sunderland. And what I'd like you to do is to try to identify what is being depicted in each of these pictures. All right, so this again is just our idea of getting clear on what exactly is a picture. All right, so we have our first picture. Anybody know? Okay, so that is a tiger. Very good. Second picture. That is people playing soccer. And then finally, the third picture. Anybody else? Right? Could be a whale, could be a car. My Canadian mind went to Zamboni when I first saw this. This one, we don't know what it is. So there is something about a picture that allows you to identify what it is representing. And the idea of fidelity in a picture. A high fidelity picture looks like what it's trying to represent. Low fidelity picture does not look like what it's trying to represent. But you can see that none of these pictures are photorealistic, right? None of them are what we would consider to be the product of, I'm trying to say this as nicely as possible, the product of a developed system of drawing, right? We'll stick with the first one. They're not photorealistic. And yet everybody was able to take a look at this one and say, oh yeah, that's a tiger. Most of us, maybe it took a little bit longer, were able to take a look at this and say, oh yeah, that's people playing soccer, but something failed here where we were unable to say, yeah, that's definitely a whale, or that's definitely a car, or that's definitely a Zamboni. So we can see that some pictures are successful, some pictures are not. And if we take a look at the picture that was successful, we can see that it represents a tiger. It's a picture of a tiger. But it's not the only way to draw a tiger. So this is one way that you can have a picture of a tiger. I mentioned draw. I don't mean just drawing, because this is another way to have a picture of a tiger. You can actually take a photo of a tiger. And you might think that it's very easy to explain. How do we perceive a photo of a tiger versus the actual tiger? This is not something that I'm going to get into too much as we go through picture perception, but I'm just going to say this. This tiger was taken from a particular position, right? This image of a tiger was taken from a particular position. And if you're not in that position, when you are looking at this image of a tiger, it should look weird and distorted to you. So the fact that this tiger looks proportional, looks photorealistic, and none of you are in the correct position to view this tiger means that something is going on in our minds that allows us to perceive this as unchanging, invariant, even though we're all in the wrong position to view this picture of a tiger. And again, that's something that's special to picture perception. If you're in an environment, you cannot be in the wrong position. Whatever your position you're in is the right position. But if you have a picture in perspective, there is one single position in front of that picture that's the correct position. And if you're not there, a lot of visual theories would say that that image should seem distorted. The fact that it doesn't is, again, one of those mysteries of what's going on. So we have a picture of a tiger, picture of a tiger, picture of a tiger. We have another picture of a tiger here. Now this one is highly stylized, but still readily recognizable as a tiger. And then we have another picture of a tiger here. And this is one of those interesting things that pictures can do, in the sense that when I said, hey, we got a picture of a tiger here, almost nobody had this confused reaction on their face and said, hey, you know what? That's just the head of a tiger. That's not actually a tiger. That's just, part of a tiger. There is that ability also when you're looking at pictures to have this sort of perception of the object as a whole rather than just the object as a part. Because when you see a severed head in a picture, you don't have the same sort of perception or reaction that you would if you saw a severed tiger head in the actual environment. It's a very different type of perception. So we have all these different pictures of all these different, we have all these different pictures of all these different tigers, and there is something the same about all of them. And any visual perception theory would have to be able to explain why in all four of these instances, we were able to say, yep, that's a tiger. We have different levels of realism in pictures, as we just saw. So you can have things that are line drawings, which don't duplicate very much of that ambient optic array or the information that's coming in from your environment. You can have images that are very photorealistic, that basically recreate all of the ambient optic array that's coming from the environment, except maybe you're in the wrong place. And then you just have some real weirdness that happens with pictures and how they represent the objects that are depicted. So this is a famous painting by René Magritte called Treachery of Images. And basically the text there says, this is not a pipe. And he was making the point that images are not the things that they represent. There's a sort of treachery in images. They're almost lying to you, because you take a look at that and you say, if somebody put that picture up and said, what is this? You'd be like, oh, that's a pipe. And René Magritte was making the point that that is not a pipe. And this is actually one of my favorite examples, partly because Scott McCloud, in his Understanding Comics treatise, did a whole thing on this particular image. And we'll just go through it a little bit just to kind of show you how weird and wonderful picture perception can get. So Scott McCloud said, here's a painting by Magritte called The Treachery of Images. This inscription is in French. Translated, it means, this is not a pipe. And indeed, this is not a pipe. This is a painting of a pipe, right? Well, actually, that's wrong. This is not a painting of a pipe. This is a drawing of a painting of a pipe. N'est-ce pas? Nope, wrong again. It's a printed copy of a drawing of a painting of a pipe. And then for you guys, actually, it's a projection of a printed copy of a drawing of a painting of a pipe. And then it's not just a printed copy of a drawing of a painting of a pipe. It's 10 copies, actually. Because if you were reading this comic, it's 10 copies of the picture. 6, if you fold the pages back. And he ends with saying, and this is one of the reasons why I also study comics, because there's many interesting things that happen there. He goes, do you hear what I'm saying? If you do, have your ears checked, because no one said a word. Clearly that's meant for when you're reading alone. But in this case, you can actually have your ears checked, because Scott McCloud does not sound like Dr. Yudishevich. That's not his voice. So again, we're dealing with this really weird territory of picture perception that allows us to do certain things, opens up possibilities of viewing the world in certain ways, and has a lot of examples that kind of playfully indicate that we're not dealing with the real thing, and yet somehow we're very much able to perceive it as the real thing. So all of this adds to this kind of mystery of what exactly is going on when we're perceiving pictures. All right, so what is a picture? So let's get to some actual definitions. And we're going to start with a definition of my own that I developed as a grad student. And I am going to present it here for the sole purpose, well, a couple of purposes, but for one purpose, that it sucks as a definition. So I just want to let you guys know that this was my reaction when I proposed this definition to my supervisor and got his feedback on it and just realized, wow, this is a horrible definition. So we're going to put this up as a kind of sort of explanatory case of when a definition, what are some red flags when you're looking at a definition. So that's one reason that I like to include this one, because those red flags were explained to me in that particular meeting. But I also just like to put this one up because it was so wrong, so incredibly wrong, and yet here I am today. So just to sort of put that out there, failure is not a barrier to success. Failure is actually a prerequisite to success. And if you want to be successful, you want to fail early, you want to fail often, because that's the best way to get from here to knowing a little bit more about the topic that you're trying to understand. All right, so what is a picture? What was my definition that I proposed? So I came up with this definition and I thought to myself, wow, this really sounds great. And hopefully you'll think, at least at the beginning, yeah, that's not unreasonable. So I defined a picture. I go, a picture is a non-propositional visual representation on a two-dimensional plane. And we're going to call this the non-propositional definition. So what does it mean to be non-propositional? So we know visual representation, that just means that it is a visual stimulus. It's something that our visual system is picking up. On a two-dimensional plane, that just means that it's on a flat surface. So we're not talking about statues. We're talking about images on a flat surface. But what is this non-propositional aspect of it? So what does that mean? Well, let's take a look at two representations of Mona Lisa. So we have the picture of the Mona Lisa painting, and this is an imagery representation, right? This is an image of the Mona Lisa. But you can also represent the Mona Lisa via propositions, via statements. So you can say something like, well, we're taking a look at a Caucasian female. She's got long dark hair, hands folded on her lap, mysterious smile, and you can keep going on and on and on with a description of this until somebody would be able to get a pretty good idea of what the Mona Lisa looked like, to the point where somebody could potentially see the image of the Mona Lisa and say, oh yeah, that's exactly what you were talking about. That's the image that was described. So this could be a representation of the Mona Lisa. But even if I had a complete listing of all the descriptions of Mona Lisa in this propositional form, nobody would say that that's a picture of Mona Lisa. Nobody would go up to there and say, yeah, you know what, that actually is a picture of the Mona Lisa. So we have this idea that a picture of Mona Lisa is actually a visual representation It's on that 2D plane, but it's not propositional. It's a representation that's not just a list of all the descriptions of Mona Lisa. And again, we have this idea that this image is something more than just a description of the image, that it is this, again, non-propositional representation. And when you can take non-propositional representations like the pipe and then mix it with propositional representations, this is not a pipe, and there you get that tension that a lot of artists like to experiment with. All right, so that was my non-propositional definition. And I walked into that meeting and I thought, you know what? Wow, I've probably got something here. This is going to be great. And very, very quickly, my supervisor, who I will say, his name is Dr. John M. Kennedy, one of the greatest human beings I have ever had the pleasure of meeting. So just know that he was very kind and very understanding and very much the person that you want to hear that you're wrong from. And he did tell me that he was wrong. He didn't pull any punches when we were trying to get to the truth, but he was about the nicest person that you could get negative feedback from. All right, so he told me, he goes, this non-propositional definition of a picture is actually a really, really poor definition. And then he went on to explain why. So why is this a poor definition? It sounds reasonable. Most of the faces in this room weren't looking at it going, what have you done? They were looking at it going, seems like it makes sense. That list of statements about Mona Lisa, that's not a picture of the Mona Lisa. So what's wrong with this definition of, what's wrong with this non-propositional definition? The big red flag, and this goes for any definition of any concept that you ever come into contact with. And this is one of the other reasons I wanted to talk about this. Anytime you come up across a definition and it's a negative definition, that is a huge red flag that it doesn't actually define the concept. And the person proposing the definition, I'm going to tell on myself right now, the person proposing the definition doesn't really have a grasp on the subject. And what do I mean by a negative definition? Well, this picture is a non-propositional visual representation. That doesn't say what a picture is. That says what a picture isn't. And that's the negative aspect of it. It is saying that it is not a propositional definition rather than what a picture actually is. And if you're ever dealing with a definition, again, this is just for you to go on further in life. If you're ever dealing with a definition that says, oh, I can define this, it's not this, and it's not this, but it doesn't tell you what it actually is, that is an incredibly poor definition. And it's an indication that the person giving that definition might not have a very firm grasp on the subject at hand. So why is the negative definition a bad definition, right? Because it's not immediately apparent why this is not something that can work. Well, the reason that it's a bad definition is because it has to be circular. Negative definitions are almost, I believe, logically required to be circular. So what I mean by circular is that when you take a look at a negative definition, I can tell you what visual representation is. I can tell you what a two-dimensional plane is. When I'm saying what is non-propositional, then I can say, well, it's anything that's not linguistic, right? Anything that's not just a series of statements, like pictures or music or sculpture. And then I say, well, what is a picture? Well, it's something that's non-propositional. Well, what is non-propositional? Well, it's anything that's not linguistic, like a picture. Well, what is a picture? Well, it's something non-propositional. Well, what's non-propositional? Well, you know, it's a picture. Well, what's a picture? And you can see that it just devolves into this circular definition that sounds like you're getting somewhere. It sounds like you're making progress, which is why I walked into that meeting full of confidence. But we didn't actually make any progress because we're just spinning our wheels in this circular motion because we've defined something as what it's not, which leads to that round and round game that you just can't get out of. All right. So what is a picture? Let's get back to some examples of the weird and wacky stuff that we're trying to explain. So pictures can represent many things. Pictures can represent things that exist. Okay, so pictures can represent things that actually exist in our world, like lions. And once again, I like putting up these images here because they're kind of dual meanings in here. So this is a picture of lions that do actually exist in our world, but not one of you had this surprised look on your face when I put this picture up and said, oh my goodness, giant ghost lions? Where? Where is this taken? I need to know, giant ghost lions, what's going on? That's not your first thought when you see this. And I put this one up because we are going to talk about metaphorical pictures. So you almost immediately understand that this is not, and there's information in this picture to tell you these are not giant ghost lions. But what it does mean is that these lions are important. They're the kings of the jungle, even though it's not a jungle. They rule over this land, you know, everything that the sun touches and all that kind of stuff. So again, how do pictures do this? We'll get to that a little bit when we talk about metaphorical pictures. But importantly, pictures can represent things that exist. Pictures can represent things that do not exist, right? So we can draw pictures of unicorns. And to my knowledge, unicorns don't actually exist. So they can depict things that are seen or can be seen, right? So a basket of fruit. These are things that can be seen in the real world. But pictures can also depict things that cannot be seen. So you can depict thought, right? So you can depict a person's thoughts in a picture. And again, these are things that cannot actually be seen. And if you can see thoughts, let me know. We'll work on some experiments and we'll grab our Nobel Prize. But it's something that cannot be seen. And one of my favorite examples of how artists try to represent things that cannot be seen comes from comics, and it comes from Sue Storm, The Invisible Woman. So for those of you that might not know, hopefully this will be more common knowledge after the Fantastic Four, new Fantastic Four movie. Hopefully they'll finally get it right. We're 0 for 3 with 2 fun ones, but no, I meant that 1 fun one and 2 kind of dreary ones. But anyways, Invisible Woman, the name is, it's on the tin, what she can do. She can turn invisible. That's one of her powers. She can turn invisible. How do you draw invisible, right? How do you draw invisible? How do you show invisible in the real world? It's almost a conundrum. It's a paradox. Like, how can you show visible, right? It's like that joke about the patient that goes to the doctor and he tells the nurse, I need an appointment, because I'm invisible. And the nurse goes to the doctor and the doctor says, tell him I can't see him, right? Like, how do you see invisible? You don't, but you can represent invisible. So artists throughout the years tried to come up with ways that would represent the idea that Sue Storm here is actually invisible. So they did things where she was transparent. They used dotted outlines, whether it was colored in white or whether it was completely dotted outlines. There have been numerous attempts to depict this idea of invisibility. And again, it's something that by definition you cannot see. But somehow you can still find ways to depict it in a picture. All right, one of the big things that pictures can do, and one of the reasons why they're so very, very important and useful in our world, is that pictures can represent space. So pictures can not only represent space, they can represent space along a lot of different dimensions. So you can represent space, two-dimensional space in a picture. So you draw a square, has no depth, it's got length and it's got width, two-dimensional space. You can also depict one-dimensional space in a picture. So if you draw a line, that line depicts one-dimensional space. If you want to be technical about it, yes, it has a height, the height of the line, but it represents this idea of one-dimensional space. It's just got length. You can actually represent zero-dimensional space. You can draw a point, and that point represents zero-dimensional space. You can get fancy and you can represent three-dimensional space. So you can represent space in a picture and even beyond three-dimensional space. So you can represent four-dimensional space in a picture. And again, this is something that people have done work on trying to figure out how to represent four-dimensional space. So you can extend, much like you extend in order to draw a cube, you extend a square in the third direction and then join up the edges. You can extend a cube in another direction on a picture and make yourself a 4D cube, also known as a tesseract. Or if you can introduce motion into your picture, so we're talking about things like film, in this case, you can actually depict a tesseract rotating in our 3D world. So if we ever came across a tesseract, which is a four-dimensional spatial structure, so it's got length, it's got width, it's got depth, and it's got something else, right? 4 dimensions of space. We wouldn't actually be able to perceive that as a four-dimensional object. But if it started spinning in our world, that's what it would look like. And we would have this impossible object that was doing these weird things because it's a four-dimensional object that is being projected onto a two-dimensional surface. So the same way that you can take a three-dimensional object like your hand and you can project a shadow of it onto the wall, and then when you rotate it, the shape of your hand becomes very, very apparent. Same way that if you rotate a tesseract in 4 dimensions, you can actually see the rotation of it in 3D space as a projection. And again, you can represent that in pictures. And this is something that our human minds are just not made to do. And one of my first statistics professors once mentioned that there is a word for people that say that they can perceive in 4 dimensions, they can visually perceive in 4 dimensions, and that word is liars. And he said that because we're just not made to perceive in 4 dimensions. Because, again, let's go back to Gibson and ecological psychology, we have never lived in a 4-dimensional space. Almost. You're about. My immediate answer would be no, just because I've honestly never come across it. I've never heard of that occurring. You can make things that look like tesseracts, but if they start moving or upon closer inspection, they fall apart. The thing that it reminds me of is the book Wrinkle in Time. Has anybody ever read Wrinkle in Time? I don't recommend the movie, but the book is amazing, and I think it's Madame Longo. I'm probably butchering her name. Anyway, Wrinkle in Time. Highly recommend it. They build a tesseract in A Wrinkle in Time, and it immediately teleports their father to another planet, and they have to go save them. And they come. I don't want to read the book; it's amazing. But they come across these 3 women, the witches, and no, Miss Witch, Miss What. And it's been a while since I read the book, but it's really just this mind-bending kind of really interesting exploration of a lot of different things. And me as a sort of perception person, there's one point where they take them to a two-dimensional world and the children just about die and they pop out of the world, and one of the magical ladies is reprimanding one of the other ones, and the other one is like, I didn't know, like I didn't realize they wouldn't be able, to survive in that two-dimensional world. So I think if we did ever build a tesseract, who knows what it would do. It's kind of, I mean, you can imagine that we live in multidimensional space, but we just can't perceive it because, again, it's not, for our survival. But the other way to think about it is that if you ever had if you ever had the ability to go into a higher dimension of space, you would unlock abilities that you almost can't imagine, wouldn't make any sense. So, for example, if you were able to go into a 4th dimension, there is not a bank vault in this world that you could not get into and take all the money out of. And the reason for that is it's kind of like an argument from analogy. So I'm using the board more today than I ever did before. So let's say that we live in a two-dimensional space. And I have a bunch of money, and I put it in the vault. Closed up all the edges of the vault, right? You're a two-dimensional being, which means that you're confined to this chocolate. You're trying to move. You're trying to get in. There's no way to get in. You can't get my money. My money is safe, right? If you're a three-dimensional being, you can go into that third dimension. You can go over here. You can come in here. You can take all the money, pop back out, go over here, and you're on your way. So that's if you're three-dimensional and you can go into a two-dimensional world. If we were able to build a tesseract, probably just based on that, let's keep it out of the hands of bad actors. It would probably be extremely dangerous. And now I kind of want to build a tesseract. Anyways, I was about to say that we do kind of have a fourth dimension that is related. It can also be represented in pictures. And this other fourth dimension is time. So time is another dimension. We can't move as freely through it as we move through space. So you can go lengthwise, you can go widthwise, you can go depthwise. We move through time, but we move through time at the rate of 1 second per second, and that's kind of fixed. But if we could move through time, or if you did want to represent these four dimensions, you can represent those in a picture. So for example, here's a nice example of an image of a little girl throwing a ball. And again, when I show this to people, nobody ever thinks to themselves, oh my gosh, what is that? Decatuplets, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever 11 identical twins would be. Nobody ever thinks that. Everybody was always like, oh, well, here's a little girl. And we started off at the left here, and she's picking up a ball. And it continues on, and she throws the ball, and she's pleased with the result, and she's super happy. That is something that you can represent in a picture. You can represent this idea of time. All right, so what is a picture? Let's get to a better definition. And this one comes from Gibson, 1954. And one of the things I love about Gibson, I talked about being wrong. I talked about being wrong early and often as one of the gateways to success. When researchers talk about Gibson, they always talk about Gibson followed by the year. So somebody will say, oh yeah, Gibson 1954. And then somebody else will say, well, Gibson 1977. And then somebody else will be like, well, don't forget about Gibson 1979. You can't just say Gibson, because Gibson was completely fine with being wrong and changed his mind a lot. And that's one of the reasons he made the massive contribution that he made. But in 1954, he gave himself he gave it a shot, and he said a faithful picture. And what we mean by faithful is one that, as far as I can understand it, looks like the thing that you're trying to represent. So it's recognizable as a picture of what you're trying to represent. A faithful picture was a delimited surface so processed that it yielded a sheaf of light rays to a given point, which is the same as would be a sheaf of rays from the original scene to a given point. That is, when the adjacent order of the point of color in the cross-section of one corresponded to the adjacent order in the cross-section of another. That is a lot to decode. What I will say is that basically what this is saying is that you have a delimited surface. That means that you have a picture frame. You have a surface that is not extending off into forever like an environment does. And you are going to process it, you're going to paint on it so that it makes a pattern of light, the sheaf of light rays at a given point, which is the same as the light rays that you would get if you looked at the thing in the environment. So basically it's our tiger picture of our tiger example. That's what you're trying to do when you're making a faithful picture. So the core of his definition, the core idea here is this point-by-point projection theory. And what that point-by-point projective theory is based on, it's based on the idea of perspective projection. So it's based on the idea that perspective, as it creates the optic array, as we've seen before, that perspective structure, it also underlies our ability to perceive pictures. So perspective pictures and geometry, we'll talk a little bit about perspective, and we'll probably end with this definition today. But your perspective geometry and that perspective structure, that determines the information that's available to vision. So when you look out at the world, so you have your eye there, you're looking out at the world, you're looking out at that jogger in the world, the light that goes through your through your pupil, projects onto your retina. That is determined by perspective geometry. And one of the big discoveries in the Renaissance was by an architect and thinker named Brunelleschi. And what he discovered was basically how to use that geometry to recreate that projection on a picture surface. So Brunelleschi, back in the 1400s, and there's a statue of him, came up with this mathematical solution, came up with the geometry required to do perspective. And Brunelleschi is one of these really, really interesting minds that ever existed, because there's a lot of accounts that he was an intuitive genius, in the sense that he was able to solve problems, but didn't have the kind of formal training or the sort of mathematical proofs required to convince others of these things, or basically take them through his reasoning. So there was this one famous story from Brunelleschi. He was an architect, and he wanted to get this contract. He was proposing to some very rich individual. They wanted to build a dome. They wanted to build a tower with a dome, and they wanted to see the plans for the dome. So there was a bunch of architects there, and he came there to give his proposal, and they were like, well, what's your proposal, Brunelleschi? And his proposal was, look, I can build you the dome. I can do it. I know how to do it. I can't explain it to you, but I can build it for you. And that wasn't very convincing. So Brunelleschi said, well, let's give it a test. Let's take all the architects over here and give them all an egg. And whoever can balance the egg so that it stands on, lengthwise up, whoever can balance the egg so it doesn't fall over, give them the contract. So all the architects, tried to balance the egg. They held the egg and they let it go. And of course, the egg fell over, the egg fell over, the egg fell over. So Brunelleschi comes up and he takes the egg and he taps it slightly on the bottom until it depresses the shell just a little bit. And then he stands it up, walks away, and it stays upright. And all the architects said, well, we could have done that, if you just showed it to us. And he goes, yeah, you could. And the same thing is true of my tower. So let me build my tower and my dome, and he got the contract. Anyways, he came up with perspective. He was the guy. Perspective geometry for pictures was not one of these things that developed in different places at different times. It's not like the invention of the bow and arrow, where if you go into different cultures, they just independently invented the bow and arrow on their own. It's not like calculus, where Newton and Laplace, I believe, simultaneously independently invented calculus. Perspective geometry came up once, and basically the idea is that you have a real object, like that big block in the real world. You have a picture surface, and you trace the light from the block to your eye, and where it intersects the picture surface is where you draw that point for the object in the real world. So the corner of the block A, capital A, intersects the picture surface at lowercase a as it travels to the eye of the observer at O. That lowercase a, that's where you draw the point for that corner of the image. And basically, just kind of give you a more schematic version of this. Let's say that you have this schematic world. We got a tiled surface. We got ourselves a tree. That's the object that you're trying to draw. We got ourselves an observer. That is the person that is painting the object. We got ourselves a picture surface. And what perspective geometry says is that you take a point on that real object, project a beam of light from there to the observer. That's going to intersect your picture surface at a particular point, and that's where you draw that point of the object. And then you do it for another point on the object. That light travels to the observer at the same, staying in one point, and then reproduces that on the picture surface. And you continue to do that for point after point after point. And then eventually you'll have enough points where you have that image of that tree, you'll have that depicted tree, and it'll be a perspective picture of that depicted tree. And that's how you do perspective geometry, to make a faithful, as Gibson was saying, picture of that tree. So the idea is that the pattern of light that is coming from the tree will be reproduced by the pattern of light that is in the picture. So the light coming from the tree will be the same shape as the light coming from the picture, even when the tree is not there. And you can kind of have fun with this. Again, Rene Magritte did a lot of paintings that played on this idea. So as an artist, he would have been aware of perspective projection, and he played with this idea. So here we have one of his paintings, The Human Condition. And this is a painting inside of a painting, but it kind of illustrates the idea of perspective projection, because that painting right there in Magritte's painting is reproducing at that position what you would have seen if you were looking at the beach in the real world. Now, he's forgotten the wall, but again, the idea is that that image reproduces what you would have seen in the real world if you were there. So he did a series of these called The Human Condition. So this one is another one depicting a grassy forest. This one is called The Call of the Peaks. So again, looking out, I guess, through a window off a cliff, you can reproduce the mountains. And then this is just something that artists like to have fun with, and you'll see a lot of things like this posted online. So you can do this, and if it lines up at the point that you are taking the photo, if the picture of this person with Tinkerbell and their backpack, if that lines up with the real world and the picture, the photo that's taking it, that means that you have that perspective geometry of this person's face being preserved. And that's why all the points look like they line up. And you can have fun with this with points that are not your own. But again, to the extent that they line up with what was there in the real world, that means that they match up in that perspective geometry. Yep. Yes. Yeah. Aha's music video of Take On Me would super count. And does anybody not know Aha's video for Take On Me? Okay, so do yourself a favor in the upcoming week. Read A Wrinkle in Time. I probably, now that I've talked about it a little bit, we'll go back and try to read it this week. Watch Take On Me by Aha. Actually, you know what? I had a couple of examples that are not going to be as good as that particular example. So let's just do it. This is the video for Aha, Take On Me. All right, so it starts off with this girl reading a comic book in a diner. We don't need the captions. All right. So she's reading the comic. She's flirting with the guy in the comic, I guess. And she actually gets pulled in. And then the rest of this is animated images of it, but there's this one, this is probably the best example of it. This is perspective projection at play to the extent that they could rotoscope. So they use rotoscope to the extent that they could mimic what was in the picture with what the real individual is doing, means that in the picture they matched up point for point, at least for the edges of this individual, what was being there in the real world. Right, do a little bit more. There we go. Okay. So that is, I think, where we're going to end today. We're going to finish up with our look at picture perception in the next class. So we got to our better definition. There's a even betterer definition coming down the pipe, and then an even betterest definition after that. But all of that will be done next time. So that is it for today. Weird and wonderful picture perception. I'll see you all next time.